they're back here. All right. So today we're gonna be going over strings and chips, no, strings and lists and math. No, we did math. Okay, so we're gonna do strings and lists. All right. So, uh let's get started. These are strings. Does everyone remember strings from yesterday? We all know what kind of so I just y'all got that. So we'll just go, yeah. So we'll just go one by one through these chips. Um, yeah. So let's start with the easiest, pretty straightforward. Two string. You can put any type of port into the left side, and it'll output a text equivalent. So if you were to put like a player in it, it would output the player's name. If you were to put a color in it, it would output the name of the color or like the hex value if it's a custom color. Or like just anything of the sort. If you hover over a port with your maker pen, uh, with the connect tool, some some chips output like what the text is on that port. So then if you were to connect it, it would then output that data. All right. And then next we got string format. String format lets you format like strings. Obviously, it's in the name, but the way of how you do that is you could type something into the top part, and then you can reference stuff in the additional ports, and you can even configure it and add up to like 64 ports, I'm pretty sure. So right now I have two. And if I want to reference this first box, or first port, I would write this in there, and then whatever's in that first box is what will appear in my text up here. Uh, and then if I want to do the next box, I'd replace that 0 with the 1. If I want to do my third box, I do 2. So on and so forth. Does that make sense? How do you use string format? It's a little confusing at first, although if you like use it, then like it'll. Okay, we'll make an example later where you guys will use string format, and like once you use it once, it clicks pretty easily. Um, all right, then we got string concat. I think that's how you pronounce it. The way of how this works is you can configure this, add as many ports as you want, and then it'll basically just put everything in these ports like back to back, and you can put a separator in between there. So I can put like a space in between each thing, and then whatever's in here will just be put back to back next to each other. Um, does that make sense? How that works? Any confusion on that? No, no
Clear as
confusion.
mud.
Oh, wait, that's not very clear.
I do. I have a question. What
Yeah.
would this be used for?
Don't do
Like,
it
what would be an
that.
example this is used for?
Um, it's like a easier format, like string format. So if you wanted to maybe like list two elements just right next to each other, instead of making a whole string format and then putting the 0 and then the 1 and 2, 3, 4, 5 or whatever, you could just put this and it'll automatically put them next to each other for you.
Something I've used list concat for is if you have a bunch of like, say, just some short string, maybe people's usernames, and you want to format them such that they're a single string, but each one is on a new line. In the separator, you would put a new line character. You just like click on it and hit enter, and then every element you put down below, instead of just being stuck together in one giant like big enormous word, they'd be automatically like spaced out on new lines.
Okay. So everything
Yep.
that you would hit enter after is going to space it out.
Yeah,
On my
everything
screen.
that string concat can do, you can also do on string format, but sometimes it's just more convenient to do it automatically with just the one separator.
Yeah. I was gonna say that sounds sweet.
Yeah. All right. Next up, we got string length. This will tell you how many characters are in a string. It just outputs a whole number as an integer. Yeah. All right. Then we got string contains. Have you ever been on like a Google Doc and then you do Control F to find something? It's fine if you haven't. It's kind of like that, where you can put a string in the top, and then the sequence is like what you're looking for. And then if that exact sequence, and it is cap sensitive, is inside of that string, it'll output true. If it's not, it'll output false because that is a Boolean. You have a question? Yeah. The control F. Yeah. Yeah. So it's pretty much that. Then string index of. Uh, it's like the same thing, except this will tell you where it is in the string. So you put one string in the top, and then you put what you're looking for in the second string, and then it'll tell you where it is in the string. And if it's not in the string, it'll output -1, meaning it is nowhere to be found in there.
The index of the character it will give you is 0 based. So the very first character will be 0 if it's at the very start, and the next one will be 1. It won't start at 1, it'll start at 0.
Yeah. That applies to all of these things up here that use integers except for string length. If there's nothing in the string, it'll be 0. All right, then we have string length is just you put a string in and it outputs how many characters are in that string. So it's like yeah. All right, then we got string split at, and this lets you put a string in, and then you can put an index, which is like how far into the string you want it to be split, and then it'll split it into 2 halves. We're going to explain lists today, so just note this outputs a string list, and we'll go over right after strings how you can use list. So yeah, just remember that. These are all lists down here. Here we have string split. The way of how string split works is you put your string in the top, and then you put a second string, and this will look for certain things in there. Like whatever you set it to look for, it'll look for that. So you could put like the word. No, I'm not gonna do that. You could just put a long string in there, and then make the second string like an A, and then it will get rid of the A and it'll split it into a list. So if I have a word with 3 A's, this will output a list with 3 items in it. Does that make sense? How that works? Well, we might need to come back to these string chips that use lists once we explain lists, because right now it doesn't totally make sense. So then this is similar. White space is like spaces, like in your text, like a space, or like a down space. I think those are both the white space. I don't think there's anything else. All right, then let's come back up here. These are not list chips. So string replace, you put your string in the top, then you put a pattern, like something you're looking for. So once again, if you've ever used Control F, sometimes you have the option to replace what you looked for. So you will put a string in, and then the pattern you're looking for. So if I put like an A and my word is apple, right? Then I will put a replacement, and it'll get rid of that A, and in its place, it'll put whatever I put in that replacement port. And I can make it as long as I want it, or as long as the string can be. You have a question? No? Okay. So like if I put apple in the top and made the pattern I was looking for A, and I made my replacement like D, it would output the pull. It's not a real word, but that's what would happen to it. String trim, I'm pretty sure that gets rid of the white space at the beginning and end. So if you accidentally have spaces like at the beginning of text or at the end of text, or like a down space at the end or beginning, it'll get rid of it. Is that true, Will? I've never used this chip before.
Say that again.
String trim.
It will replace white space at the start and end of the string. So if you have spaces or like
Oh
lines,
yeah,
it'll
that's
just clear them
what
out
I
at
said.
the two ends.
All right, now we have string substring. This is useful for like having a set length of a string. So you can put a string into the top, and then you can set your start index of it. So if you want it to not start at the very beginning of a string, you can have it like cut in like 2 characters or like as many characters as you want, and then make the length of it however long you want. And so if I'll use apple again. If I have the word apple and I cut in 1 character, it would be changed to just pull, right? If I made the index 1, it would be pull. Then if I made the length of it 2, or if I made the length of it 3, right? If I made the length of it 3, it would then output just pull. I don't know, but does that make sense how that works? Kinda. All right. All right. Now we'll go over to here. These two are super simple. String to upper. Put a string in, and it changes all of the characters to be uppercase letters. So if I have a string that is just A, it'll output A. Obviously, it doesn't do anything to like numbers and symbols because they can't be changed to like uppercase, but anything that can be changed to uppercase will be changed to uppercase. And string to lower does the exact opposite. It'll change everything that's uppercase to lowercase. That's all that does. Okay, now we have the parse chips. You can kind of think of these as like string to blank, so string to Boolean, string to float, string to int, string to color. That's pretty much what it is, but like we went over what parse Boolean is yesterday. If you guys remember, if you put true in, it'll output true. You put in false, it'll output false. And if it can't find anything, then the second Boolean will be false. It's the same idea for all of these. So if I put a number in the parse float, it'll output that number as a float. And if it can't find a number, it'll say parsing success false. Same thing with integers and colors. And parse color is actually neat because you can even put stuff like blue and it'll find that color for you. Like you can put blue or you can put a hex code in it. And that's super useful. So I think that's all the string chips. Yeah, that's all the string chips. So, does anyone have any questions? No? All right. Well, should we? Yeah. So like here, if I put into this parse int, like I'll put like a 5, right? Not if you can't spell the words, I don't think. Wait, can you, Will? I don't think you can. I've never tried that.
Getting the list chips.
Let's find
What was
out.
the question?
They're asking if you can spell the word and parse. Yeah, no, you can't do that. It's got to be a number, but it just converts it from a string to its type.
Oh yeah.
So if I put a 5 in here, it says the result is 5. You guys can hover over it, see it's 5, and it successfully parsed that, which is important. Then same thing for all of these. Like if I type true, it'll output true. If I put 50.7, this outputs 50.7. It's literally just converting it from a string to a whatever kind of port it is. Does that make sense? How parse chips work? All right. All right. Any questions on any of these chips before we move on?
Not now, not until I get to use them.
It's too many. Yeah, there are a lot of chips. All right. Should we do an example with just the string chips before moving to lists?
I don't have anything planned unless you did.
I didn't.
We're gonna have an example at the end that includes both lists and strings.
Oh, actually, no,
So
I
we'll
have a
cover it all.
good use case. We'll go over format because that was confusing. I'm gonna make it so when you click a button, it says hello, your name. All right. Here's a quick example for strings. I'm gonna grab a button, and then I'm gonna grab a toString and a string format. And I'm going to connect the toString to the second port on that string format. And the format in here, I'm just going to write this inside of it. Hello with the brackets. And then I'm going to get a set button text. Is that what it's called? Or is it button set text? Button set text, okay. And then connect that to the button. And now, whenever I click this button, it'll say hello snug. And if one of you guys click it, it'll say hello and then your name. Because the format in this string format is hello and then whatever's in the second value, and the second value is just the player who clicked the button. Does that make sense?
Makes dollars.
Did this person crash?
Your circuit's frozen.
Uh-oh.
Jesus.
Oh,
there
Oh,
they
he's
go.
back.
okay.
He is risen.
Did that clear up how to use string format? Yeah. Okay. If you have any questions later, always feel free to ask. All right, so now we're going to go on to the list chips. I'm going to give it over to Will.
Okay, so lists are kind of like regular types, except instead of just having one, as the name list would imply, you have a whole list of them. So lists can be any length between 0. You could even have a completely empty list, or you could go up to, currently the limit is 65, but I hear very soon we're going to increase that to 4,000. So
Will,
within
you
each
didn't get all
list,
the chips.
there's more. Oh, I think
I was
MakerBit did
wondering.
something weird.
So I'll remove.
So any list has also a type. So whereas like a bool is just a bool, if you want to have a list, you can't just have like any list. You're gonna have a list of, like for example, a list of bools or a list of integers. So there's like a base type like stored inside the type of the list. So there's quite a few chips to work with lists. One of the most important ones is called list create. As the name implies, it just creates a list based off of a set of items. So like some of the other chips we covered, you can configure this chip and add more ports up to currently 65. And all of these input ports have to be the same type. And so like if I were to wire floats into here, this would automatically create a list of type float where it's in order. So lists, something important about lists is that they have indexes. So if you put values into here, the first one, this is also 0 indexed, similar to how we were talking about strings. So this is going to be index 0. And then the next one is going to be index 1, which will be important when you use the list get element chip. So this takes a list. So I could, for example, wire this list output of list create into list get element. And then it will take an index. This is just an integer. They're always whole numbers. So if I say get element at index 0, it'll give me this first value. If I change this to a 1, it will give me the next value. And the output type, this will match the same type as the inputs because it's just getting the same object. Note that if a port is a list. It'll have these little like square brackets on it. It'll usually be the same color as the base type. So if I were to wire a bool into this, it would all turn red, and then we'd have the little red braces. But you can have a list of any type. We have list get count. This one's pretty helpful. You just give it a list, and it tells you the integer number of how many elements are in that list. Kind of similar to strings, kind of like the analog to string get length. We have list add. Notice this has an execution on it, because unlike most other types, lists are considered like objects. The details of this aren't too important at a beginner level. Most of the time, things will kind of just work. But it might be helpful to know anyway that if you have a list and you put it into a variable and then you copy that into another variable, if you make a change to one list, it will also change the list in a second variable. So you're actually like changing state, which is what the exec is for. So you give it a target. This is the list you're going to be adding an element to, and then you give it an item of the correct type, and it will just take that element and it will just shove it at the end of the list. So it'll just be the last one. There's list insert, which is similar to list add, except you actually tell it where you want it to go. You give it the index, and it will put it in that slot, and everything after that index will get pushed up by one index. List set element, this is kind of similar to if you were to just take an element at a specific index and you want to replace it with some new value. So you give it the list that you're operating on, the index that you want to set, and then the new value that you want to put into that index. So it's kind of like list insert, except it replaces the value instead of inserts a new one. List copy, as I was saying earlier, lists are objects. So if you were to take the same list and write it into two variables, it'll really be the same list. This one will actually make it a whole distinct object. Most of the time, this probably won't really matter for any work you'll be doing anytime soon. List concatenate. Concat is just short for concatenate. Similar to string concat, it just takes two lists and it merges them together. It makes a new list that has all of the elements of the first list, and then at the end of that are all the elements of the second list. Then it's a new list. If you try to do any of these chips and it would give you something that exceeds the limit, which is currently 65, it'll just either give you an error or just like truncate it at 65. But as I said, it's going to be increased quite a bit pretty soon. List get all indices of. This is also kind of similar to the string equivalent. You give it a target list and then an element. So if I have a list of all the players in the room, there's actually a chip get all players, which will return exactly that. It gives you a list of the players in the room. And then I said get item like will chill. It will tell me the number. Oh, sorry, I'm thinking of get first index. Get all indices of will return you a list of numbers everywhere that element is. So if it's only there once, it'll just return a list of that one number. List get first index is kind of similar, except instead of returning a list, it will just give you the first index that was in that list as integers. List contains, also similar to the string equivalent. You give it a list and an item, and it tells you whether or not the item that you give it is anywhere in that list. If it's not in it at all, it'll return false. If it's in it once or more than once, maybe it's the entire list, it'll return true. These chips honestly aren't too helpful. They kind of just operate iteratively over the entire list, like list divide. I think the way this works is it takes the first element, divides it by the next one, and then just keeps going down until it gets to the end. Similar for multiply, subtract, and sum. Some could be kind of useful if you want to add up the entirety of the items in a list. List min and list max are kind of cool. They only work on lists that have an inner type of either integer or float. So if you give it one of those, it will tell you either the highest value for list max or it will tell you the lowest value for list min. So that could be kind of useful for some things. List remove at, this is kind of the opposite of list insert. You give it a target list and then an index that you want to remove that element at, and it'll remove it. List remove item, this is kind of similar to list remove at, except instead of giving it an index, you want to give it, you give it an item that you want to remove somewhere in the list, and it'll just like automatically find wherever that index is and delete the item that was there. This will run for everywhere that you have that element that you give it in the list. There's also list remove item first. This will just remove the first time it finds it, and then if you have more, it'll just ignore it. List remove last, you give it a list. It just takes the very last element in the list and deletes it. You could do this yourself if you used a list and you said get count, and then you did list remove at, and then the last element in the list of indexes. That would just do that. List clear. This will take a list and it will delete every object in it until it's an empty list. Random from list. This one's kind of cool. You'll give it a list, and when you run it, it'll randomly pick an element inside the list. You could also do this one yourself without the chip if you just use like a list. If you just used like an integer get random number chip, and then you like use list get element. So when you run it, it will update this value port, and that value port will stay the same until you run it again. That's kind of just the case for all chips that have exec ports. If it has an exec and then like a data output, that will only update when you run it again. List shuffle. This takes a list and then it will randomize the order. So anywhere you just want randomness, you want to shuffle it around. That's what you want there. And then we have list sort. This is kind of the opposite of shuffle. It will take a list and then it will sort it. So it only takes lists that are either list float, list int, or list string, and it will sort them in order. For numbers, it'll go like lowest to highest. For strings, it'll be alphabetical. And there's an ascending port on it. This is a bool. Defaults to true, but if you toggle it to false, it will go in the opposite order. So it'll go highest to lowest. Snug, do we have list added? Okay, over here. Yeah. These orange chips, they're in beta. They were just recently added like a couple of weeks ago. They kind of treat lists as if they were sets. In set theory, sets are kind of similar to lists, except that the order doesn't really matter. And we consider elements of a set to only exist once. Like if you take a set and you add an element again that's already there, it's like mathematically considered the same set. Sets aren't like a concrete thing that we have implemented in Rec Room, so we kind of just approximate them with lists. So that's kind of like the motivation behind a lot of these new orange beta chips. So this one, list add if not contains. As with the other ones, it takes an exec and a target list, and then it takes an item. It's similar to list add, except if the list already has the element, it just won't add it at all. If it doesn't, it will add it. And there's a success output port. This will return true if it didn't have the element and it was able to successfully add the element. I have a few more beta ones. List intersect. This, you will give it two. So you can kind of think of it as like a Venn diagram. You have one circle. These are all the elements in list A, and you have another circle, all the elements in list B. It will return the set of elements, which is in the intersection of both of those circles. So it'll only take the elements that are in the little overlapping region, and then it'll return that as a new list. List union, this is similar. You can still think of that Venn diagram with two circles, except instead of only the overlap, it will return the entirety of elements that are in either list. So if it's in the overlap, it won't return it twice. Because like if you were to use string concatenate, it would just like put the items in there twice. But this will kind of just filter it out. So it's every element that was either in circle A or circle B. List accept, I haven't used this, but I'm assuming what it does is it takes the first list, and then it will ignore all of the values that were in the second list. So if you think of back to the Venn diagram, it would kind of cut out like that overlap from the first circle, and it would kind of give you like a C shape, all elements in there. List distinct, this would kind of just convert it into a set where it will take any item that was in a list like multiple times, and it will only give you the ones that it'll basically just make it so each element is in the list once, like exactly once, if it was there at all. Cool. Any questions? Cool. Yeah, there's a lot of chips. You can do a lot of stuff with lists. Snag, is that everything for the chips today?
Did you go over the variables?
Oh, right. So we have variables. These are similar to the regular variables, except that obviously they're lists. So just like you can store just some value like in a bool or an int or a float, you can store a list. Note though that with lists you can't make them synced. It's kind of an annoying shortcoming at the moment. Hopefully we'll have synced lists at one point. So if you make a variable of lists, like a list variable of a set of elements, it'll only be set locally. It won't just like automatically copy over. You'll also notice that like, whereas with a bool, you could like click on the little input port and you can set the default value. Same with most of these. That's not the case for lists. You can't just like automatically make a list on the input port. For that, you'll want to use something like either list create or any of these other chips which make a list, and then you wire it in there and you can set it to that. They do support cloud variables though. So you can have cloud lists that are like saved for a player.
All right.
Cool.
So now we're gonna move on to our example, which is gonna be taught by Will again.
Okay, so something that is kind of useful that uses both lists and string manipulation is, for instance, if you want to have some, maybe it's like a moderation tool where you want to move this one person in your room into a specific location. So something you can do to accomplish that is make like a multiple choice prompt, because there's a chip which will give you a multiple choice list of options that you give it. And we want to take like the username of every person in the room and present that as an option in the multiple choice chip. So there's a few chips that will make this pretty simple. First, we're going to want the get all players chip. And as the name implies, this is just a simple chip with no input ports that returns a list of players. So the output here is a list type, and like the inner element type of the list is player. So that's all good. Let's take out our prompt multiple choice chip.
This took me 10 minutes to build.
Okay, so here's the prompt multiple choice chip. There's a lot of ports on here. Most of them aren't really too important for this example. You can look at them later if you like. And one port that we are going to want is answer choices. So this is a list of strings. So when we run this chip, every element that we want to provide as an answer choice should be of the type string. You'll see that our get all players chip does not return that. It actually just gives you a list of players. So what we're going to have to do is we want to convert it into strings. Let's do the username. Wonder it's called player prompt multiple choice. I might have said like something slightly different. So let's think about how to do that. Oh, also, this will get all players. For this specific example, we want to exclude ourselves. So let's figure out how to remove the local player. And fortunately, one of those new chips that we just covered that's currently in beta will do that. We can use a list except. So we're going to give it the list of all players first. Cool. So that it knows we're dealing with lists of players. So let's remove ourselves. So that shouldn't be too bad. We just need to wire ourselves into this port, but you'll see that it is also a list. So we can't just say default like local player directly as a default value. We need a list. So that's also pretty simple. Let's just get a list create chip out. And this will automatically make a list with the given inputs. So even though it's just one item, we still need to make it a list. Single element lists are completely valid. So let's configure this chip, especially with two inputs. We only need one, so let's configure it and we can remove the input. So it's just a one element list. And when we wire this up, this port here, this is a player list because it knows from right here. So when we wire this up, this will automatically adapt. So this input is also a player type. So it defaults to invalid player. Let's click on that with the connect tool once to make it a local player. So cool. So if I hover over get all players, it'll tell you that the count is 17. That's kind of like a nice little feature. It tells you how big the list is. So there's 17 of us in the room apparently, and then we're running list accept to cut out the local player. And when you look at that, it'll say that there's 16 players. So that's exactly what we want. We want everybody but ourselves. And like if I were to run this, this would be a list of everybody except Will Chill. If Snug were to run it, this would be everybody except for Snug. It's all dependent on who you are on your local account. Cool. So we have the list of players, everybody except ourselves. Now we want to convert that into strings. So there's a few ways to do this. Firstly, you could use a 2-string chip. If you wire up the list into a 2-string and then hover over the output, you'll see that it actually will be able to convert the list into a string. So it starts with like an open square bracket, and then it has the first element in the list, that person's name, and then there's a comma and a space and the next person on the list, and then it keeps going until the end, and then at the very end there's a closed curly brace or a closed square bracket. So what we can do is we can use string format, or sorry, string substring. And first, we want to cut off the curly braces at the square brackets at the start and end. So we just want the username separated by commas. So let's do that. Let's take the string, and we're going to wire it into the string input. And then we have 2 properties here, index and length. So index is where you start, and this is 0 based. So there's only one character at the start, the open square bracket, that we want to skip over. That's at index 0. So we want to start at index 1 over. So let's take index and increase it to 1. And then we have length. This is how long our substring wants to be. And if you think about it, we have this whole string. It's a big list. We only want to cut out 2 characters, the end square bracket and the start square bracket. So that's 2 characters. So the list or a final substring will be the length of the entire string minus 2. So that's pretty simple to do, which is a couple chips. Let's get string length. And this chip will automatically get us the length of our string. It looks like it's 139 for me. It'll be slightly different for you because you're cutting yourself out of the list. And then we want to subtract 2. So let's get a subtract chip out. Yeah, exactly. Subtract 2. So in the second input, let's make that 2. So the input length is 139 for me, and then it turns to 137. Let's put that into length. And then if I hover over it, it's kind of long, but you can see that it's actually cutting off the square brackets at the start and end. So that's the first thing we need to do.
His name has 2 brackets in it.
The second thing we need to do is replace the commas and the spaces. Actually, we need to split by that. So the string split will do that. We don't need to replace them necessarily. The string split will handle it automatically. Cool. So here's the string split chip. Let's give it our string, our comma separated list of players, and then there's the divider input. This is what we want to search for, where it will split up the string. Do you have a question? Cool. So let's just edit this divider input and type into it and hit comma space. Make sure not to hit enter, because enter actually it will be a character in there, and it won't know how to split because there's no enters in the actual string. And if you hover over the string split, which will give us a list that's split up, it'll say that it's giving us a list of strings with 16 elements. And that's exactly what we want to do. So that sounds good. Let's take this output and wire it into the answer choices in the prompt multiple choice chip. There's also, like on this chip, there's a prompt title and a prompt body. These are just like the text that tells you at the top. You could say like, oh, what player do you want to pick up or something, and it would do that automatically. And there's a player input port. This is who you want to run it for. So we're all just going to run it for ourselves. We don't have to worry about running it on other people. And then you just run it. So I'm just going to take my connect tool, click and hold on the exec as the shortcut to run it. And it will, there's kind of a bug where you have to be at the right menu on your watch. But if you just go to the home page of your watch and you run it, it should prompt you and it should give you a list of everybody in the room. And you'll notice that yourself is not on this list. It's just everybody else. From there, you can kind of do whatever you want. Like it'll give you the output of the response. So this is just a string of the name. So if you want to convert it back to players, there actually is a chip, get player by account name. Oh, get player by display name is actually what we want, because when you run toString on a player, it gives you their display name. We all have account names and we have display names. Both of mine just happen to be Will Chill. But like Snug, for instance, his account name is Snug RR and his display name is just Snug. So when you run toString, it will give you the display name. So that's what we want to convert back from. And then if I run this and I click on somebody, click on Snug here, it will return the output that will now be set to Snug. And then when I run that, it will actually give me Snug as a player variable. And then I can do whatever I want with that player variable. This is just one way to do this. You'll notice this requires a beta chip. If you were to do this without the beta chip, the way you do it before is actually kind of annoying. You'd use like a list variable, and you would save get all players into the list variable, and then you would say list get element of local player. Or I guess these days you could use list remove item first. That's kind of a relatively newer chip. That will just remove it. But since you're going back and operating on the same list, you had to save it into a variable. This list accept is nice because it'll just do it all automatically right here. You'll also notice that, like, if you think about it, this is splitting the list by the comma space character. So if like one of you were to rename your display, sorry, just lag spike. If you put a comma space in your name, that would kind of break this, because it would think you're two people. Your whatever part of your name before that comma space, and then whatever part of your name's after that comma space. So it would split it up there. So if you really want to be correct about this and like do it correctly, what you could do is use a for loop chip. I don't think we've covered those yet, but it will take a list, we give it a list of players, and it would iterate over the list, and then it would convert. You could take each player and you could run it into a toString chip, and it would convert it into a string of the player one at a time, and then you could put that into a new list variable. That'd be a little bit more precise. But yeah, that's pretty much how you do all that. Anybody have any questions? Add a button. Yeah, we could add a button for this. So if I put in a button, when you're just like testing your circuits, it's pretty useful to just use the connect tool and click and hold on it. But typically when you're actually in your room, you want to have some way to actually run it without using the maker pen. So button is a great way to do that. We could take the pressed output and just wire it in there. So this will do the same thing, except I just hit the button and it'll prompt me with the list of players. Cool. Snug, where did you go? Oh, there you go. What was the assignment we had for them after this?
I can think of
Your voice is
something.
off, Snug.
Yeah, it is. Um, um, let's see what you guys can make.
Do you remember what we did last semester?
Not at all. Ducky, do you remember? No.
I
Maybe I have it. Um, uh, yeah, I don't know.
Okay, how about you make a
What all
button
did you cover?
where there's text on the button. There's also a chip to set the text on the button. Button set text. Let me pull that out.
I got it.
So how about we make something where every time you press the button, it will take, you have a list of text on the button. It does, you have a list of text in like a list create chip or something. And every time you press the button, it will change the text to the next element in that list. It'll just start at the first bit of text in the list, and every time you hit it, it will set it to the next one, and then you keep going. Something you'll encounter if you try to do this is when you hit it enough, you'll get to the end of the list. If you try to get the index of an element that is larger than the list, larger than the length of the list, you'll get an error. If that happens to you at first, that's okay. If you get to that point, that's pretty good. But if you get that working, what you can do then is you can use the remainder chip, and you can use that. And if you give this the remainder chip, if you put the first value in as whatever number you're at, like say you've hit the button like twice, this could be 2, and then the value below is the length of your list. This will kind of just like take the remainder, and it will effectively loop it back down to 0 at the very start of your list again. So you can just keep going infinitely without hitting the edge. It would just loop over the list again.
All right. Do all you guys know what to do? If you haven't finished this first example that Will made, please do that first. But if you have done that, then go find a spot and make what Will just said. If you want, we can tell you again. Yeah. Okay. I'm gonna make myself quieter though, so come up close if you want to hear it again.
Don't worry about your headset yesterday. It's all good. Don't worry about it. All right.